G'day Playmates, so welcome to another Hammer vid. It's been quite a while since I've posted up anything on my channel, so as you can see I'm back with DCS, Digital Combat Simulator. What I'm actually looking at is the Hornet Natops startup procedure. This is only for you people who, like me, are a little bit anal and would like to try to start up the Hornet as real pilots should do. It takes a little while, and I mainly did this because quite often people sort of say, you know, you're into flight sims, and if you actually were in the cockpit of the Hornet, could you start one up and, you know, and fly it? And quite glibly, I would answer, yes, of course I can. In fact, that's not true. Because for the simple reason that there are a number of startup routines in the Hornet that aren't actually simulated in DCS. So you'd actually need to read the Natops manual, which is about a 900 and odd page downloadable PDF that actually is the official manual for and guide for starting up the Hornet. So what I've actually found is in the DCS download section, of which I'll put a link down below on this video. There is a guy who's actually put together a training vid which replicates the Natops setup. So I've got it up and running at the moment. It's on pause, and as you can see here, it says, on this mission, we will learn how to do a detailed carrier cold start on the Hornet, following the procedure of the Natops manual. We are actually not on the super carrier. We're on the Stennis because that's the way he's designed it. I have actually changed the skin in this mission via the mission editor, but I wasn't actually game to put in a super carrier in case it actually, in fact, it actually crashed the mission. So, yeah, okay, here we go. Let's crack on. I am in VR. The other thing is also I am recording in widescreen, which has taken me a little while to put together, but I'm happy that that's happening now, so you don't sort of see that awful square sort of picture in the middle of your screen with the black bars on either side. So, yeah, let's crack on. Just for those who are in VR and want to record in VR, the widescreen is actually, and 4K is actually done via a third-party app called SideQuest. All right, here we go. And, of course, I'm using voice-activated controls because I can't see my keyboard in VR.
This training mission follows the procedures described on the flight manual of the real thing, Natops F-18A BCD 2000 Flight Manual, adapted for use on the F-18C of DCS. The step numbers, when provided, corresponds to those of the real manual and are given to allow reference to it. For brevity, we will skip most of the steps of the interior inspection, only performing those that are absolutely necessary on DCS. Press spacebar to begin.
Okay, so the cool thing is there's a nice voiceover there, so I don't actually need to glance up to see the text all of the time. It is adapted for use of DCS, so that's the clue. All right, let's crack on.
If the cockpit interior is too dark, activate the flashlight with left Alt plus L. If the yellow cross cursor is not visible, press left Alt plus C to make it appear. Also, you can press spacebar to cut short long texts, in case you are repeating the mission. Finally, when clicking on a switch, remember that a left click flips the switch down or back, while a right click flips the switch up or forward. Interior check. 1. Harness lever, on the left of the seat. Forward. 7. Volume control panel, on left console. Set as desired.
Okay. TACAN up. Weapons down. RWR down.
14. Exterior lights panel. Set strobe light to bright, to indicate that there is a pilot on board.
Which I think normally it defaults to bright anyway.
15. Throttles. Confirm that they are at the off position and are in sync with your actual HOTAS throttle.
Actually, before I do that, I think I'll put the stick in. There we go. A bit more realistic. Yep. They're in sync.
16. Parking brake. For INS alignment, it is critical that the parking brake be engaged. Check that the handle is vertical. The handle is rotated with a left or right click and the mouse wheel is used to pull or stow the handle. 17. Anti-skid switch. The anti-skid is a system that prevents wheel lock-up during braking at speeds over 10 knots. Set to on when on shore, as we are currently on a carrier, set it to off. Interior check, instruments panel. 1. Master arm switch, check that it is on safe.
Check.
4. Select altitude source, set alt switch to radar. Interior check, right console. 3. Wing fold handle, should match the current wing's position. Adjust with left or right click and then use the mouse wheel to lock.
Check.
10. Interior lights, set as desired. This concludes the interior check. Next, we will start the engines. Engine start. 1. Battery, check status. A. Battery switch, set to override. B. Emergency battery voltage. Check. After being a minimum of 5 seconds in override, check a minimum voltage of 23.5 volts. C. Battery switch, set to on. D. Utility battery voltage, check. After being a minimum of 5 seconds in on, confirm a minimum voltage of 23.5 volts.
Copy.
The battery only powers the following items: the auxiliary power unit, the engine fire warning systems, the intercom system, to communicate with the ground crew, the cockpit utility light, the canopy mechanism, the integrated fuel engine indicator display. Only once at least one of the engines is running, only then its generator will give power to the remaining aircraft systems. In order to communicate with ATC, we will ask the ground crew to connect external power. Press the / key, or either PTT button on the HOTAS, the communications menu will appear. Select F8, ground crew. Click F2, ground electric power. Select F1, on. Press spacebar once the ground crew has connected the external power.
Okay.
1. External power switch, set to reset. This switch must be positioned to reset before external power can be applied to the aircraft buses. The reset position is spring-loaded to norm. Once on norm, after passing by reset, the aircraft buses are connected to the external power. Press spacebar once you have reset the external power connection.
So I don't really know whether... okay, thanks, crew chief. I don't actually know whether real Hornet pilots on board a carrier actually use external power. Maybe you guys can confirm that for me. Anyway, we've got external power to reset.
2. External ground power switch 1, set to be positioned. Hold for 3 seconds while the avionics undercool warning temperature switch performs an internal bit test. This switch provides power to mission computers 1 and 2. Left DDI. Maintenance signal data recording set.
Oh, okay.
External ground power switch 2, set to B position, where it provides power to right DDI, HUD, radar, INS and EHSI, TACIT,
Oh,
air
wow, that's
data
a fair
computer,
old list.
COM 1 and 2 radios, radar altimeter, communication system control, ADF beacon, ILS, data link, IFF, engine monitor display, standby instruments, KY58, UFC panel. External ground power switch 4, set to B position, where it provides power to intercommunication control set, flight control electronic system. 3. Turn on the left and right DDI by right-clicking twice on their off, night, day knobs. Turn on the HUD and MPCD by rotating their brightness knobs clockwise. The master caution light comes on when any of the caution lights or caution displays come on. Also, an audio tone is heard. You can reset the master caution by clicking on it. Its light goes out. Click on master caution now to reset it. Clicking the master caution when it is unlighted causes the uncorrected caution and advisory displays on the left DDI to reposition to the left and to a lower level, provided there is available space vacated by corrected caution and advisory displays. Try it. Click on master caution now and observe the caution and advisories restack on the bottom of the display. 4. Set COM 1, COM 2 and ADF as desired. For this mission, we will tune the COM 1 radio to preset 2, which correspond to the ADC frequency. Turn the dial using the mouse wheel until a digit 2 is shown on its visor.
Noisy buggers.
We will now contact Air Traffic Control, a DC, to ask permission to start engines. Press the COM 1 PTT button on the HOTAS, or use the right Alt plus / keys. The communications menu will appear. Select F5. ADC. Click F1. CVN 74 Status. Select F3. Request startup. Press F12 once the ADC is given permission, and then press spacebar to continue.
Okay, I don't think this is actually working in DCS at the moment. Engine startup. Nah, it's not even listed. So I don't know whether that is a current DCS bug or not. Alright, so let's just let's hit the spacebar and pretend that they've given us permission.
5. Warning and caution lights, DEST, by clicking and holding the switch on the LT panel. Confirm that all the lights illuminate.
Yep, all good.
2. Fire test switch. Hold on test A, with a right click and hold, until all 5 fire and bleed air voice alerts are heard. Observe left and right fire, APU fire, L bleed, and R bleed lights are on. If left DDI is on, observe L and R bleed off cautions are displayed.
Engine fire left. Engine fire left. Engine fire right. Engine fire right. APU fire. APU fire. Bleed air left. Bleed air left. Bleed air right. Bleed air right.
Oh, good.
Wait 7 seconds for the test tape to rewind, then repeat the test with test B.
Alright, test B.
Engine fire left. Engine fire left. Engine fire right. Engine fire right. APU fire. APU fire. Bleed air left. Bleed air left. Bleed air right. Bleed air right.
All good.
The right DDI is currently on the bit test page. Stop the blinking by pressing the stop button. The bottom section of the left DDI is where all the cautions and advisory messages appear. We will place the FCS page here. press the menu button. Next, select the FCS page by clicking the highlighted button. The Auxiliary Power Unit, or APU, is a small turbine engine used to generate compressed air, which will be used to turn the main engine's turbine until it reaches enough speed to allow its igniters to start the main engine. The APU, in turn, is started by means of a small hydraulic motor powered by the APU accumulator. The aircraft battery provides electric power for the APU ignition. 3. On the warnings panel, check that the APU ACC caution light is off, meaning that the APU accumulator has enough pressure to start it. Next, turn the APU switch to on to start the APU. The APU ACC warning light will illuminate while the APU starts. Wait for the green ready light of the APU, next to the APU switch, to illuminate. Press spacebar once it is lit.
Okay, it's lit.
Okay, with the APU running, we can now start the engines. Either engine may be started first, however, starting the right engine first provides normal hydraulic pressure to the wheel brakes. After the APU ready light is on, place the engine crank switch to R. This opens the right air turbine starter control valve and APU air then powers the air turbine starter, ATS. The ATS in turn, cranks the right engine by way of a gearbox and power transmission shaft. After the right generator comes online, the engine crank switch will automatically return to off. 4. Engine crank switch, set to R, with a right click. 5. Right throttle, advance to idle, using the HOTAS or the right shift plus home keys, once the right RPM is at 15% minimum, as seen on the IFEI display. Advancing the throttles from off to idle, opens the engine fuel control shutoff valves and activates engine ignition. Ignition remains on until the engine reaches 45% RPM. Maximum EGD during start is 815 degrees Celsius. 7A. Check the IFEI display. Our -402 right engine at ground idle should have N2 RPM, 63 to 70%.
Check.
EGT, 190 to 590 degrees Celsius.
Check.
Fuel flow, 420 to 900 pounds per hour. Nozzle, 73 to 84%. Oil
Check.
pressure, 45 to 110 psi. Press spacebar to continue. 7B. Bleed air knob, cycle THRU off to norm. The bleed air shutoff valves close during the fire warning test and the bleed air knob must be cycled through off to norm with AC power on to reset the valves. Use right click on its outer ring to rotate it. We will now start the left engine. 9. Engine crank switch, set to L, with a left click. 10. Left throttle, advance to idle, using the HOTAS or the right Alt plus home keys, once the left RPM is at 15% minimum, as seen on the IFEI display. Maximum EGD during start is 815 degrees Celsius. Engine crank switch, check off. After the left generator comes online, the engine crank switch should automatically return to off. 12. Check the IFEI display. Our -402 left engine at ground idle should have N2 RPM, 63 to 70%. EGT, 190 to 590 degrees Celsius.
Check.
Fuel flow, 420 to 900 pounds per hour. Nozzle, 73 to 84%. Oil
Check.
pressure, 45 to 110 psi.
Check.
13. External electrical power, disconnect. Ask the ground crew to disconnect the external power. Press the / key, or either PTT button on the HOTAS, the communications menu will appear. Select F8, ground crew. Click F2, ground electric power. Select F2, off. Press spacebar once the ground crew has disconnected the external power.
Copy. Ground power is now off.
After the second generator is online, the APU runs for approximately 1 minute, then the APU switch returns to off. 1. Waypoint 0 and magnetic variation, check. Before starting the INS alignment, we need to check that the current waypoint 0 stored on the mission computer is indeed our current position. We will check this on the MPCD display. Click on the base of the control stick to hide it, so we may have a better view. Now, let's get rid of the moving map. Click on the highlighted button. Click again on the highlighted button. Once the map is gone, select the data option to display the waypoint data sublevel. Here we can see the waypoint data. Currently the waypoint 0 is displayed. Take note of its latitude and longitude, then press F10 to call up the DCS map. Use the mouse wheel to zoom in onto your aircraft icon. Place the mouse cursor directly over your aircraft, then you will be able to see its current coordinates on the top left of the display.
Okay,
By
23,
default,
30,
the Hornet
59,
is using
20.
coordinates with degrees and decimal minutes. If the
And
coordinates of the DCS map don't match, use the left Alt plus Y keys to toggle amongst the various coordinate systems of the
23,
map.
34, 59,
Return to the cockpit
14.
with F1 and press spacebar to continue.
Check. 1.
We can see that the waypoint 0 coordinates are close to those of the map, but not identical. The reason is because of the movement of the carrier since we started the mission, but this small difference is irrelevant, since at the start of the INS alignment the ship's navigation system will provide updated coordinates. We will now check the magnetic variation of the Earth at the current location. Select the A/C option to see the aircraft data page. This is the aircraft data sublevel display, where we can check winds aloft, present position, and magnetic variation. The magnetic variation, (VAR), seems correct for this part of the world. Exit the page by selecting the HSI button on the top row. 2. Inertial navigation system, set to CV. INS is a self-contained, fully automatic dead reckoning navigation system. The INS detects aircraft motion and provides acceleration, velocity, present position, pitch, roll, and true heading to related systems. Correction signals from accelerometers provide constant leveling. The Global Positioning System, GPS, provides position, velocity, and time, PVT, data that can be used as an aid to the INS or as an independent navigation sensor. For aircraft with GPS installed, like ours, aided INS is the primary position-keeping mode. In AINS mode, the INS and GPS are mutually aiding each other to provide an optimal navigation solution. AINS is selected by placing the INS mode switch to IFA after a ground or CV alignment. There are 3 types of INS alignment modes that can be selected via the INS mode selector knob: CV, carrier alignment, GND, ground alignment, and IFA, radar or GPS in-flight alignment. On this tutorial we will use CV alignment, selected now, by turning the highlighted knob. At this point, the INS and data link are turned on, and the CV aligned display appears on the HSI display. CV alignment has 3 types of alignment options: RF, CBL, and manual. Currently we are using the cable alignment option. The aircraft is now data linked to the ship's inertial navigation system. The time display on the CV aligned display should be incrementing, and the quality value should be decrementing. Wait a bit, until an OK appears beside the quality.
Okay, this will
The
take
alignment
quite a...
will take a bit over 8 minutes. A real pilot would proceed with other post-start steps in the meantime, but, for instructional purposes, we are performing the steps in strict sequence. However, you may use the time acceleration feature of DCS to do this step quicker. First, press left Ctrl plus Y to display the status bar at the bottom of the screen.
Okay, now I do know that hitting standard heading will facilitate the INS a lot quicker than over 8 minutes. In fact, you normally get an OK after about, I think, nearly 2 minutes. However, I'm not going to hit standard heading in case it's going to break the scripting. So why not, while we're waiting for the INS to align, let's have a quick look around us. Okay, 2. And here we are. I am using the ASA 234 Australian skin with my own moniker, and I have my ASA shoulder patches available. 2. And here's the search and rescue helicopter in case I fall off the edge of the boat. 2. Here's our eye in the sky, the Hawkeye, and that's my phone going off in the background. Oh, I'm gonna have to leave that. 2. And what do we got here? We got the werewolves. Okay, we got a pair of Hornets. Circling on bar cap probably. 2. Yeah, there's the other one. 2. And there's the Tomcat. Fairly quiet. I don't even think he's got his engines on. Okay. All right. 9. And here's the Stennis. And the Wix actually looking quite realistic, especially in VR. 9. And these are the escort vessels. 1. And 2. And I think what I'll do is I'll just edit the video here, so I'll be back when the 8 or so minutes is up.
The OK beside the quality value means that the INS align process has finished. The no waypoints simply means that the INS data link was not used to transfer any additional waypoints, which is normal on DCS. With the alignment finished, now move the INS knob to the IFA position. This position is the same as nav, but allows the GPS to correct the INS when needed. 3. Radar. Set to operate. The radar power knob has 4 positions. Off. Standby, where all radar functions are operating except its transmitter. OPR, which is the normal mode of operation. And EMERG, which prevents the radar from shutting down due to an overheat condition. If the radar overheats, it will shut down 30 seconds after the overheat indication appears, unless EMERG is selected. But first, we will set the right DDI to display the radar screen. Press the menu button until the tactical menu appears. Next, press the radar attack button to select the radar screen on the right DDI. Good, now you can move the radar power knob to the OPR position. When the knob goes from off to OPR, the radar should begin a 3-minute time in sequence. The first 30 seconds the radar screen should have a not ready indication. For the remaining 2.5 minutes it should show test, until the radar self-test is completed. Unfortunately this is not simulated by DCS and the radar is immediately operational. Tough, it does show a multi-cross symbol because the aircraft is not on the air.
Okay.
4. Wing fold, spread and lock. For ease of taxi while on board the carrier, we will postpone this step until the before takeoff section.
Fair enough.
5. FCS reset button. Push. The left DDI is showing the FCS status display. At top center, the display presents left and right leading edge flaps, trailing edge flaps, ailerons, rudders, and stabilators positions in degrees, with arrows which indicate the direction from neutral. Move the flight stick and rudder pedals. Observe that the numbers and arrows change as control surface deflections change. On either side of the position indicators are boxes which represent the FCS redundant control channels. On the left side, reading left to right, the boxes represent channels 1 and 4 for the leading edge flaps, ailerons, and rudder, and 1, 2, 3, 4 for the trailing edge flaps and stabilators. On the right side, reading left to right, the boxes represent channels 2 and 3 for the LEF, AIL, and RUD, and 1, 2, 3, 4 for the TEF and STEP. On the lower right side of the DDI are boxes which display the status, by channel, of the CAS pitch, P, roll, R, and yaw, Y, the normal accelerometer, NACC, and lateral accelerometer, LACC, the stick position sensors, stick, the rudder pedal force sensors, pedal, the angle of attack sensor, OA, the backup air data sensor assembly, BAD-SA, and the processor, PROC. Some of these may be hidden by the caution and advisories messages. The word invalid replaces the GLM display when the FCS status display is unreliable. An X opposite one of these components indicates a failure in the channel with the X flight controls are not affected but the FCS should be reset. As the wings are folded, aileron X's are present. The FCS reset button on the FCS panel is used to reset the flight control computers after a transient malfunction. Press it now. Good. The X's on the FCS status display should have cleared. 6. Flaps, set to auto. On flight, the leading and trailing edge flaps are scheduled as a function of AOA with weight on wheels. Leading and trailing edge flaps and aileron droop are set to 0 degrees. 7. FCS reset button and paddle switch, actuate simultaneously. Pressing the FCS reset button simultaneously with the paddle switch of the HOTAS should clear the BLIN codes from the FCS page, in anticipation to performing a FCS initiated bit test. Unfortunately, on DCS this is not simulated yet. If you press the BLIN button you will see that error codes still remain.
The BLIN. Okay.
8. Flaps, set to half. Below 250 knots, leading edge flaps are scheduled as a function of AOA. Trailing edge flaps and aileron droop are scheduled as a function of airspeed to a maximum of 30 degrees at approach airspeeds. Above 250 knots, the flaps operate in the auto flap up mode and the amber flaps light comes on. On the ground, the leading edge flaps are set to 12 degrees. The trailing edge flaps and aileron droop are set to 30 degrees. With the wing unlocked, aileron droop is set to 0 degrees. 9. FCS initiated bit, perform. In addition to displaying equipment bit status, the bit control display is used to command initiated bit. For the FCS bit consent switch, on the right essential circuit breaker panel, must be held on for at least 2 seconds. This prevents inadvertent initiation of bit on the FCS for reasons of flight safety. Initiated FCS bit should not be performed with nose wheel steering engaged. 1. If wings folded, check both ailerons X'd out. Unfortunately, on DCS the ailerons don't have an X status in spite of the wings being folded.
Okay. Is that mids? No, it's not. Not on checklist. I can't remember. Is it on flight control system? No, it's not.
Two. Select the FCS Mission Computers page on the right DDI. Press the menu button to show the support menu. On the right DD. Good. Now press the bit button to display the bit failures page. Finally, press the FCS-MC button to display the flight control system, mission computers, bit page. 3. While simultaneously holding the FCS bit consent switch to on, by pressing and holding the Y key, select the FCS push button on the FCS-MC sublevel display. 4. Release the FCS button and the FCS bit consent switch when FCS A and FCS B bit display status messages indicate in test. You may want to press F2 to go into external view to watch the flight surfaces performing the test.
I can see that anyway here.
Completion of initiated bit FCS A and FCS B bit display status messages read go.
We'll go.
10. Trim check. Check pitch, roll, and yaw trim for proper movement, using the trim hat on the HOTAS while checking the surfaces values on the FCS status page.
Okay. That's all good.
Takeoff trim button. Press until trim advisory displayed. With flaps half or full, the takeoff trim button should be pressed until the trim advisory appears. The takeoff trim button will set a standard 12 degrees of nose up. This is the value used for short takeoffs. We will use it just for the controls check and later we will adjust it for carrier conditions. 12. Flaps, auto. Set the flaps to auto. 13. Controls, check. We will now perform a flight surfaces control check. Tolerance for rudder and stabilator position is ±1 degree. A. Control stick, cycle. Move the stick full aft. Stabilator should show 24 degrees nose up. Next, move it full forward. Stabilator should show 3 degrees nose up. Now move the stick right and left. Stabilator should show 20 units differential. Check also differential trailing edge flaps.
Copy. And copy.
B. Flaps, full. Below 250 knots, leading edge flaps are scheduled as a function of AOA. Trailing edge flaps and aileron droop are scheduled as a function of airspeed to a maximum of 45 degrees flaps and 42 degrees aileron droop at approach airspeeds. Above 250 knots, the flaps operate in the auto flaps up mode and the amber flaps light comes on. On the ground, the leading edge flaps are set to 12 degrees. The trailing edge flaps are set to 43 to 45 degrees and aileron droop to 42 degrees. With the wings folded, aileron droop is set to 0 degrees. 14. Flaps, half. Return the flaps to the half position. The takeoff trim button will set a standard 12 degrees of nose up, appropriate for short takeoffs, but on a carrier you should manually increase this value as per the following. 16 degrees nose up trim at weights up to 44,000 pounds. 17 degrees at weights between 45,000 to 48,000 pounds. 19 degrees at weights above 49,000 pounds. Since our aircraft weights at the moment 44,647 pounds,
no,
use
it
the
doesn't.
nose up trim hat to set 16 degrees, as seen on the FCS page. If you don't know the weight of your aircraft, you can see it on the checklist page of the support DDI menu. 16. Air refueling probe, speed brake,
okay, so we got to send that to, to 16.
Cycle. A. This is the well-known 4-down check. Begin by activating the pitot heat. B. Next, open the ram air scoop by placing the avionics cool switch on the emergency position. C. Extend the fuel probe with a right click on the probe switch. D. Lower the launch bar, by setting the switch to extend. E. Extend the speed brake, using the HOTAS or the left shift plus B key. Press spacebar once extended. On the real Hornet, the plane captain would make a go-around checking that everything extended. On DCS we can do it ourselves, by pressing F2 to go into external view and take a look around. Press F1 to return to the cockpit, and press spacebar to continue.
2. Okay, launch bar down, probe up, speed brakes up, all good. Check completed. 1.
F. Place the pitot heat switch to auto, with a left click. G. Retract the fuel probe, with a left click on the probe switch. H. Raise the launch bar, by setting the switch to retract. I. Retract the speed brake, using the HOTAS or the left control plus B key. Press spacebar once retracted. 17. O-Bogs control switch on. The onboard oxygen generating system provides a continuously available supply of oxygen for the aircrew while the aircraft engines are operating. Engine compressor bleed air is cooled, routed through the inlet air shuttle valve, and then directed to the O-Bogs concentrator. Place the O-Bogs switch on the on position, to begin oxygen supply. 18. Oxygen flow knob on. The oxygen flow knob is used to control the supply of oxygen to the aircrew. This knob has 2 detent positions, on and off. It is possible to place the oxygen flow knob in an intermediate position, which may result in a reduced flow of oxygen. The knob should always be fully rotated to the on or off detent position.
Yep, all good.
No. 20. Fuel. Bit test and set bingo level. 28. Perform the fuel bit. The fuel bit is performed from the fuel page. Display it on the right DDI, by clicking the menu button until the support menu is shown. This is the support menu page. Now press the highlighted button, to display the fuel page. This is the fuel page. To initiate the fuel bit test, click on the FL bit button. The built-in FL bit tests the entire fuel low warning system. A satisfactory test result includes a fuel low caution being generated within 10 seconds of starting the test, a voice warning should be heard, and a master caution generated. The FL bit option is boxed during the test.
Oh, good.
B. Set the bingo level. The bingo fuel level is set on the IFEI. Its fuel display window contains 3 digital counters to provide dynamic fuel quantity indications. The upper digital counter displays total aircraft fuel quantity. The middle digital counter displays total internal fuel quantity. A digital counter legend is displayed to the right of the upper and middle counters. T. Total fuel. I. Internal fuel. The lower digital counter displays the selected bingo fuel quantity, in 100-pound increments. The up and down arrows on the IFEI provide bingo level adjustments from 0 to 20,000 pounds in 100-pound increments. Bingo counter scrolls if arrow keys are depressed for more than 1 second. For this mission, set the bingo to 5,000 pounds. Good, the bingo level is now set to 5,000 pounds. 21. Altimeter, set. The standby altimeter is a counterpointer type. The counter drum indicates altitude in thousands of feet from 00 to 99. The long pointer indicates altitude in 50-foot increments with 1 full revolution each 1,000 feet. A knob and window permit setting the altimeter to the desired barometric setting. This setting is also used by the air data computer. Set it to 29.92 mercury inches.
It is already set to that. So hit the spacebar to continue.
22. Radar altimeter on. The radar altimeter indicates height from 0 to 5,000 feet. Operation is based on precise measurement of time required for an electromagnetic energy pulse to travel from the aircraft to the ground terrain and return. The height indicator, on the instrument panel, consists of a calibrated scale from 0 to 5,000 feet, a push-to-test switch, a low-altitude index pointer, an altitude pointer, an off flag, a low-altitude warning light, and a bit light. Turn the mouse wheel clockwise, over the radar altimeter knob, to turn it on, and keep turning it to set the low-altitude index. Set it to 40 feet, as the carrier deck is 60 feet above sea level, to compensate for the initial sink when the aircraft leaves the catapult. Left-click and hold on the radar altimeter knob, to perform its bid test. A green light comes on when the bid is finished. At that point, release the mouse button. Voice alert and or warning tone, and visual warnings are activated when the aircraft is at or below a selectable low-altitude limit. A red light on the radar altimeter comes on when the aircraft is below the low-altitude index. A whoop, whoop warning tone is heard.
Well, good.
23. DAWS boxed. The Terrain Awareness Warning System, DAWS, is a safety system that warns the aircrew of impending controlled flight into terrain. The TAWS option, located on the aircraft's subpage, allows the pilot to disable or enable the system. This page is reached by pressing Menu, HSI, Data, /C. The system is enabled when the TAWS label is boxed. It should be enabled by default.
As we will. So what was it? Menu HSI. Okay. And data. Yeah. Okay. And aircraft. And yep, TAWS is boxed.
24. Mission data. Enter. Mission data can be manually loaded into the mission computer through the Memory Unit Mission Initialization (MUMI) page, accessible from the Support menu, or automatically loaded into the mission computer using a data cartridge. Unfortunately, these aspects are not simulated yet.
Okay.
25. Bit, note degraded, fail. On the right DDI, open the bit page and take note of any items that have status degraded or failed.
Weapons degraded and all degraded. Don't know what AUG is. Okay, and actually displays are getting a little bit bright. I think dusk is setting in, so let's just go to night and night and night and night. Okay, so spacebar.
26. Weapons, sensors, as required. A. Activate the radar warning receiver by clicking on its power button.
Okay, let's just get that out of the way and
B. Enable countermeasures dispense, turning its switch to on. Once on the air, the system will perform a bit test and then go into standby. Its status can be checked on the EW page of the tactical menu.
okay. Countermeasures.
C. Activate the ECM jammer, turning the ECM knob to standby. 27. Standby attitude reference indicator, uncaged. This is a self-contained instrument to indicate aircraft pitch, roll, and yaw. Uncaging it just using the mouse wheel. Press spacebar once uncaged.
And uncaged.
28. Attitude source, standby. Set the attitude switch to standby. Verify INS attitude data is replaced by standby attitude data on the HUD check agreement of standby and INS data.
Standby.
29. Attitude source, auto. Once checked, leave the attitude switch in auto.
And checked.
30. ABOGS system. Check. On the real Hornet, this check requires pressing the ABOGS monitor push button, which is located on the seat bulkhead, but this item is not simulated on DCS.
Seat bulkhead. Yeah, okay. I think we'll be getting there.
31. ID. Enter 3-digit Julian date and event number via the UFC currently not simulated.
Yeah, there you go. That ain't going in.
32. Canopy either full up or full down during taxi. Taxiing with canopy at an intermediate position can result in canopy attach point damage and failure. Do not open or close the canopy with the aircraft in motion. Close the canopy by left-clicking on the highlighted switch. Hold until the canopy is fully closed.
Okay.
Congratulations. You have completed all the steps of a realistic cold start procedure. Press spacebar to exit the mission.
Okay, mission over in 5 sec. The winner is blue. Training is completed. And back. So there you have it, guys. Hope you found that useful or even interesting. And as I say, the link for that particular mission will be available. And until next time, have a great Christmas, and I'll catch you later. Okay, bye.